Example 2, graph using transformations. So part A, we're given the function f of x equals negative 1 over x plus 2. So we want to first identify the parent function. So if we ignore the negative sign and this plus 2, we can see we have a 1 over x. So our parent function here is going to be 1 over x. So then we're going to be listing key points and features on the 1 over x graph, and then we'll list the new corresponding key points and features on negative 1 over x plus 2. Now we remember when we look outside the grouping symbol of a function, we're looking at vertical changes from its parent function, and when we look inside the grouping symbol, we're looking for horizontal changes. Now in the case of a rational function, a 1 over x, the grouping symbol, if you will, is the fraction. It's the denominator. So if I look in my denominator here, there's nothing changing about this x. Nothing's being added, subtracted, multiplied, etc. There's no negative sign down there. So the way that this is written, there's no horizontal changes because nothing changed about the denominator. So again, with these rational functions, your grouping symbol is the denominator. So if I look outside of it, I see I've got a negative sign and a plus 2. So we know when we multiply a function by a negative on the outside of the grouping symbol, we know that's going to cause a vertical reflection about the x-axis. So my first transformation, we have a vertical reflection about the x-axis. So we know that we're going to multiply the y values of those points in our parent function. We're going to multiply them by negative 1 to cause that transformation. Also, outside the grouping symbol, now we have a plus 2. So we know when we add outside the grouping symbol, that's going to shift the graph up 2 in this case. So we have a vertical shift up 2 units. So we know to perform that transformation to our key points on our parent function, we're going to add 2 to the y values. So I want to list my key points on my parent function, and we also want to include key features, which we know are the asymptotes. So we'll list our 1, 1, negative 1, negative 1, and then we have our vertical asymptote, x equals 0, and our horizontal asymptote, y equals 0. So those we need to generate. We need to know the shape and those key points of that parent function. So now, we see that nothing's going to change. There were no horizontal changes, so our x values will remain the same. So it'll stay an x value of 1 and x value of negative 1. But then we need to multiply the y values by negative 1 and then add 2. So I need to multiply 1 by negative 1 and get negative 1. Add 2 to negative 1 and we get positive 1. So that point after those transformations actually remains the same. Now, negative 1, so if I take my y value of negative 1, multiply it by negative 1, I get positive 1. Add 2 to that and I get 3. So I'll have negative 1, 3. Now, the asymptotes need to transform as well, if applicable. So if we look at a vertical asymptote, a couple things. A vertical asymptote is a set of x values, where all the x's are 0. So you can think of it as if there's no horizontal change, then you're not going to change an x value. So you can think of that vertical asymptote like an x value. So if there's no horizontal changes, there's no changes to the x. It'll stay x equals 0. But with the y values, horizontal asymptote is a y equals, so it potentially could change here with vertical changes. So if I multiply the y values by negative 1, if I multiply 0 by negative 1, that would just stay 0, but then when I add the 2, it's going to change to 2. So this horizontal asymptote shifts up 2 units. So just think when they're shifting, those asymptotes will shift as well. So if we make a sketch, so we'll plot the points 1, 1, negative 1, 3. And then right away I would sketch those new asymptotes because that sets up your grid where you're going to fit your boomerang or your branch shapes within that grid. So we still stay on the y-axis, x equals 0. Now that horizontal asymptote, that y equals 0, shifted up 2. So now we have a horizontal asymptote up here at y equals 2. So now, once you sketch those, I think it makes it easier to sketch these branches in between the grid now. So now, we'll have a branch in the upper left portion of the grid, which no longer corresponds to a quadrant now because we bumped that horizontal asymptote off of the x-axis. And then we've got a branch here in the bottom right. Again, so when you guys sketch these, make sure you don't accidentally do something like this. You want to show that you understand this branch approaches this horizontal asymptote but never crosses it. And as always, we'll label our points here. So we have -1, 3, and 1, 1. And again, we want to make sure that those asymptotes are labeled. Now let's just practice writing out some end behavior and behavior of the function around the asymptote. So if we look at our end behavior, so we can say, as x approaches infinity, so we're going to the right. So as I trace along the right branch, x gets infinitely larger. You can see the y value, it's flattening out, and it's approaching, shoot, I did that again, sorry. It's approaching that horizontal asymptote where y is 2. So we can say, as x approaches infinity, f of x approaches 2. Now let's look at the other end, the left. As we trace along the left branch and x gets infinitely smaller as x approaches negative infinity, same thing's happening. It's flattening out and approaching a y value of 2. So we can say, as x approaches negative infinity, f of x also approaches 2. Now let's describe the behavior of the function, the behavior of the graph, around the asymptote, the vertical asymptote. So we can approach that vertical asymptote from the left and the right. So let's start from the left. As x approaches that vertical asymptote of 0, from the left, so that's that 0 minus. So I've got a branch to the left of this vertical asymptote. As I approach it, as x gets closer and closer to 0, we can see that y value is increasing infinitely. So as x approaches 0 from the left, f of x approaches positive infinity. And then we can also approach that vertical asymptote from the right. So as I look at the right branch, as I get closer and closer to an x value of 0 on the right side, you can see the y values decreasing infinitely. So you can say f of x approaches negative infinity.